Hi, class. Hopefully, you've had a good weekend. Again, just priorities that you look after yourself, look after the people in your household. So, we uh, we finished last class looking at what organic compounds are and organic chemistry. So, first thing we'll do here is go over the answers. And again, most of you are already doing this, but I'll just remind you, I'd like you to submit your answers. I am keeping a check of in terms of completion marks, and then also I will be marking the assignments that you're handing in, like the coronavirus assignment and any future assignments. Okay, so make sure all that stuff gets handed in. And most of you are doing that, so keep it up. Okay, so let's look over the questions here. So number one, what is organic chemistry? The study of, so that's carbon-based compounds. Okay, so compounds that have a carbon skeleton. What elements do all organic compounds contain? So they all contain carbon. And then the other element most organic compounds contain is also hydrogen. Okay, and then there are other additional elements that are present as well, but those are the two most common. Number three talks about the versatility of the amount of compounds carbon can form. So the reason why carbon can form so many compounds is it's able to form long chains, which we call polymers. It's able to single bond, double bond, or triple bond. It's able to contain branches. It's able to contain different functional groups. And then it's able to become a closed structure, which we call rings, right? So, for example, the glucose molecule is an organic compound. It's basically a hexagon. Okay. The other thing, sorry, I think it's a pentagon. The other thing with the carbon is that all those things I just finished mentioning, you can have a combination of all those, right? So again, that adds to the versatility of organic compounds. So number four is basically asking you to identify whether it's organic or inorganic. And I don't think I mentioned inorganic the last class, but inorganic simply means it's not organic. Okay, so A would be organic. B would also be organic. Okay. C is inorganic. Okay, so it's a metal carbide. D is organic. E is inorganic. That's a carbonate. F is inorganic. There's no carbon there. G is organic. H is inorganic. I is inorganic. So that was, remember, one of the exceptions, carbon dioxide. And then J is organic. 5, the definition of a hydrocarbon is something that contains hydrogen and carbon. The chemical name of the simplest hydrocarbon would be methane. Okay, CH4. And so methane's primarily used for heating. For fuel for heating. 7, 3 elements are present in alcohols would be carbon, hydrogen, as well as oxygen. 8, the definition of a solvent is something that dissolves something else. So typically we use water as a solvent. Like say we have salt, we'd put that into water, so water would be acting as a solvent, but you can have other solvents as well. 9, a use for each of these. So methanol is used in fuel. Ethanol is a typical solvent. And then C, isopropyl alcohol is basically you use that to disinfect wounds. Okay, so that's basically rubbing alcohol. Okay, 10, the difference in molecular forming between each of the following pairs. Methane and methanol, the methanol is going to contain the OH. Okay, so methane CH4, methanol will be CH3OH. So basically what happens is when you stick on an attachment, you drop a hydrogen. ethane and ethanol, ethane is going to have 2 carbons, so that's going to be C2H6, and then ethanol will be C2H5OH, and then propane is going to have 3 carbons, so that's going to be C3, and then I think you're going to have C3H8, and then isopropyl alcohol will be C3H7OH. Okay, and then 11, you've got some drawings here, and so this is basically, again, this would be considered a hydrocarbon, right? And so what I'm talking about is when you add a functional group, in order to do that, you have to remove one of the hydrogens. Okay, and just with this one here, this would be considered, another way to describe this would be considered something that is saturated. And when I say saturated, what that means is you put in the maximum number of hydrogens. Okay, so when we say an organic compound is saturated, it has the maximum. So that would be organic. B, methane is organic. And also, just coming back to this one here, you notice how carbon's got 4 bonding sites. Like I said, it can be double or triple bond. And then if we were to double bond, say we put a double bond here, then what would happen is we'd have to take 2 hydrogens out. Okay, because it can only have 4 attachments. C would be inorganic, so there's a carbonate. D is organic, E is inorganic, and F is organic. Okay, just let me know if there's anything I just went over that you need a little bit more clarification on. I can do that. Okay, so what I want to look at today is the reaction types. Okay, so you should be copying this down. Okay, so these are all different types of reactions, and we've looked at chemical reactions already, and I had you balancing them. So it's kind of a continuation of that. What we're going to look at is the different types of chemical reactions. When you can identify the type, you should be able to predict what the products are going to be. Okay, so if you can follow the pattern. So first one here, this is called a synthesis reaction. Okay, so you should be writing this down in your notebook, or if you have pieces of paper, and just kind of keep all that paper together. Okay, so synthesis is when you have 2 things that are going to be combined. Okay, so it's a combination reaction. So what you look for, so let's look at this one here, magnesium and oxygen gas. Okay, so magnesium, there's magnesium metal. Okay, and remember we talked about 7 elements that when they're on their own, we said that they're what we call diatomic, right? So oxygen, when it's on its own, is diatomic. That means that 2 has to be there. Okay, so just by looking at this, you should be able to identify this as a synthesis reaction because you have these 2 individual parts that are going to combine. Okay, so if we were to write out the reaction for this, that would be Mg plus O2 giving you MgO. And remember, when we're talking about how does the Mg and the O combine, that's when you're using your combining capacities, right? So remember, Mg is 2 plus, oxygen is 2 minus, and then you get Mg2O2, but we don't want, we want that in simplified, so that becomes MgO, right? And then afterwards we have to balance. Okay, so you have 2 Mg's here, you have 2 O's here, 1 Mg and 1 O being multiplied by 2 gives you 2 for each of these. Okay, so remember the same number of each atom on both sides. Okay, decomposition is the opposite. So a decomposition reaction is where you have one thing by itself on the reactant side that's going to split apart. Okay. Okay, so here is calcium nitride. So again, if we're trying to figure out what does that look like, calcium is 2 plus, nitrogen is 3 minus, so you get Ca3N2. So now if this thing is by itself on the reactant side, it's got to split up into its component parts. And so again, calcium is just going to be by itself. It's a metal. Remember, that means it's on the left-hand side of the periodic table. Nitrogen is another one of those diatomics. So it's not just going to be N, it's going to be N2. And then again, we have to balance that. Okay, so decomposition is the opposite of synthesis. Okay, next one let's look at is what we call single replacement. Okay, so there's two types of single replacement. It depends on if the individual element is either a metal or a non-metal. Okay, so for the first one, if it's a metal, then it's going to switch spots with the other metal. Okay, so then B gets left on its own, and then A hooks up with C. If it's a non-metal, then it's going to switch places with the other non-metal. Okay, and so you get C by itself, and now B, A are going to combine. Okay, so it's a single switch. So metals switch with metals, and non-metals switch with non-metals. So let's look at an example here. So let's say we have lead 4 chloride and aluminum. Okay, so there's aluminum metal, Al, and there's lead 4 chloride. Okay, so remember these ones with Roman numerals, that means that there's more than one combining capacity. So this one's going to be Pb4 plus, Cl minus, and then you switch those, you get PbCl4. Okay, so this is what's on your reactant side. And so now the question is, well, what's going to switch with what? Right? And so aluminum's a metal, so this is going to switch with lead. Okay, so the two metals are going to switch together. Now, because this is PbCl4, that doesn't mean that Cl is going to combine the same way with aluminum, right? So what you have to figure out is how's aluminum going to combine? So with chlorine, so same thing, we've got aluminum is 3 plus. Okay, if you don't have a periodic table at home, see if you can find one on the web. Cl minus, okay, minus 1. And so this is going to be AlCl3. So notice you've got PbCl4 and AlCl3. So the chlorine combines differently with lead and aluminum because they have different combining capacities. Okay, and so there's our reactants, aluminum and lead 4 chloride. There's lead by itself now, and then there's aluminum combined with the chlorine. And then again, we've got to balance that out. Looking at this stuff here, we'll spend today's class and as well as our next class, Thursday's class, continuing on this. So I'll give you lots of practice on this stuff this week so you can kind of make sense of it. Okay, let's look at another one. Here we've got chlorine and calcium bromide. Okay, so chlorine is a non-metal, so it's going to switch this time with bromine. Okay, and so now you're going to get bromine by itself and the calcium chloride. Okay, so the first thing for a single replacement reaction is identifying what is the element that's by itself. Is it a metal or is it a non-metal? Okay, so after you figure that out, then you can identify what it's going to switch with. Okay, a double replacement reaction is where you have two compounds, and what's going on here, you can look at it from two different ways. You can look at it from the point of view that the positives are switching, or you can look at it from the negatives switching. Remember, the metals are positive, the non-metals are negative, but you can also have polyatomic ions, which are positive and negative. So, for example, for this one, we can look at it from the point of view A and C are switching, right? And so A now is with D, and C now is with B. All right, so let's look at an example here. Calcium sulfide and sodium hydroxide. So let's write down those two. Okay, there's calcium sulfide, there's sodium hydroxide. So what's happening here is this is a double switch. Okay, so you've got calcium is going to switch spots with sodium. Okay, and so that's going to give you calcium hydroxide. Okay, so it's calcium is +2, hydroxide is -1, so it's going to be Ca1. Well, we don't put the 1 in there, right? OH2. Remember what was wrong with that? This means there's 2 of the OH, and the way I have it here is incorrect because this just says there's 2 of the H, right? So we've got to put brackets around there. And then Na and sulfur. Na is +1, sulfur is -2, and this is why you get Na2S. Okay, and so here's your products, and then again we've got to balance it. Now another reaction we looked at when we talked about acid, bases, and salts was the neutralization. Okay, so remember neutralization, we've gone over this type of reaction before. It is an example of a double replacement, so it's simply the same idea as a switch. Acid, base, water, and salt. Okay, remember the salt's just the leftover stuff that doesn't combine to form the water. Okay, last one here is what we call a combustion reaction. So this has to do with what we just looked at with the organic compounds. So basically what happens here is when you have a combustion, what's happening is you have a hydrocarbon or organic, and I'll clarify in just a moment here, reacting with oxygen. Okay, so oxygen gas, and it's always going to produce carbon dioxide and water. Okay, so for example, if I've got methane, CH4, and I say, give me the combustion reaction of methane, or give me the reaction of methane when it's reacted with oxygen. Okay, so it's always going to produce the same things, carbon dioxide and water. Okay, so there's your combustion reaction. Now, it says here hydrocarbon, but so suppose the hydrocarbon also had a sulfur attached to the hydrocarbon, then in addition to CO2, you'd also get SO2. Okay, if it had a nitrogen attached, then in addition to CO2, you'd also have NO2. Okay, so it's the same idea. So you can have additional products if there's a sulfur or if there's a nitrogen present. Okay, so I'm going to stop there. I'm going to get you to do just these questions have these 1 to 7 done for Thursday's class. Okay, and then after we go through these answers, then I'll give you some more practice on reaction types. Okay, so there's actually a few things you need to do for each of these. So the first thing I want you to do for each of these questions is identify what type of reaction it is. Okay, so like say, is it synthesis, decomposition, single replacement, double replacement, neutralization, combustion? Okay, so first, just from looking at the reactants, I want you to be able to predict what type of reaction, what type of classification it is. And then I want you to figure out what are the products. So you have to write out the products after you know what reaction type it is. And then after you do that, then you have to balance it. Okay, so there's 3 things you got to do. Identify the reaction type, predict the products, write it down, and then balance the overall reaction. Okay, this is a good place for you to kind of get used to how to doing this, and then I'll give you some more questions on this for Thursday's class. All right, so I'll stop there. So again, ask questions if you are confused. I do have office hours. Again, it's Tuesday from 9:30 to 10:30 in the morning, but you can always, and that's if you want kind of live communication. And I also have the anytime you can send me a message on the Teams app, either in public for everyone else to see or in private, and I can get back to you on that as well if it's not as urgent and you need to speak to me right away through the office hour time. All right, so keep up the good work. Like I said, most of you are submitting everything. I can tell who's handed in what. So keep it up. If you haven't got on board yet, maybe you need some additional help, you're kind of confused with the technology, just send me a message and I'll try to assist you. All right. Bye for now.